Bismillahir Rahmanir Rahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. This lecture is the summary of confidence intervals for MEU. An important advice for me and for everyone: we should be nice to everyone. Well, there are 4 cases altogether for confidence intervals for MEU. Cases number A, B, C1 and C2. These are 4 cases. Right now I'm discussing case A and C1. I will discuss B and C2 later in this lecture, inshallah. In case A, population is normal. That means X is N mu sigma square. Population is normal means X is normal. This is the first point. Number 2, sigma square is known. And the third point is NS is of any size. So these are 3 conditions for case A. Population is normal, sigma square is known, and sample size is any size. Case C1. Population is normal. That is, X follows normal, mu sigma square, mean and variance. Number 2, sigma square is unknown. And number 3, NS is large. Say NS greater or equal to 30. So these are 3 conditions for case C1. Now check the similarities. Population is normal, population is normal. Different things. Sigma square is unknown. Here sigma square is unknown. Is any size NS is large. So these are 2 different things and this is the same thing. Okay. So since population is normal and sigma square is known, with the help of these 2 conditions, we can say that distribution of X bar is always normal with mean mu, variance sigma square upon NS. So this is the distribution of X bar of case A. This is the most important thing in sampling. You must know how to write the distribution of X bar according to the given case. Because with the help of this X bar, we can find confidence interval and we can also use this concept in testing of hypothesis. Now, confidence interval for mu. It's X bar plus minus Z times this quantity. So this is the way to form the formula of confidence interval for mu for case A. Now, case C1. Well, in case C1, population is normal and NS is large. Now, this is very important. Here, these 2 things help you to find the distribution of X bar. These 2 things. Population is normal, sigma square is known. So these 2 things help us to state the distribution of X bar. The distribution of X bar is normal. Now here, these 2 things will help us. So with the help of these two informations, population is normal, NS is large, we can say that the distribution of X bar is normal. Therefore, confidence interval for mu is X bar plus minus. Here we have to use sigma cap square. Remember, sigma square is unknown, so sigma cap square is used instead. Z times square root of this quantity. Sigma cap square over NS. So this is a way to write the formula of confidence interval of mu for case C1. So we have discussed case A and C1. Now let's discuss case B and C2. This is case B and this is case C2. Well, in case B, in fact in both the cases, population is unknown or non-normal. Is non-normal or unknown. This is the common thing in both the cases, B and C2. This is the first point. We don't know what is X. We can't write X is normal in both the cases. Number 2, here sigma square is known. Here sigma square is unknown. And this is the similar thing in both the cases. NS is large, greater or equal to 30. NS is large, NS is greater or equal to 30. Here sigma square is unknown, therefore sigma cap square will be used. Now, these two things, population is non-normal or unknown, point 1, and point 3, NS is large, will help you to write down the distribution of X bar. Now, because of these two informations, says we can use CLT here, and we have to use CLT here. Okay, this and this is the CLT, application of CLT. Central limit theorem. Same is here. Population is non-normal or unknown, NS is large. Again, the application of CLT. And what is CLT? CLT means if population is non-normal or unknown and NS is large, then X bar is approximately normal. This is CLT. You can watch my lecture on CLT to understand CLT in detail. So this is mu and this is sigma square upon NS. distribution of X bar is approximately normal if NS is large and population is unknown or non-normal. This is for case B, confidence interval, and this is for case C2, sigma cap square over NS. These are the distributions for X bar. Now, confidence interval for mu for case B. It's X bar plus minus Z under root sigma square over NS. Here X bar plus minus Z under root of this quantity, sigma cap square over NS. And here is the table. See this table. Case A and case C1. Population is normal. So X is normal, X is normal. And sigma here normal and sigma square known. So with the help of these two informations, we can say that distribution of X bar is normal. Here these two things would help you. Normal, NS is large, so X bar is normal. Here case B and C2, non-normal, non-normal, NS large, NS large. So these two things tell you that this is the application of CLT, this is the application of CLT. Listen, if population is non-normal and NS is large, then this case or these two cases are the applications of CLT. If the population is normal, then never apply CLT, never. CLT is not for normal population, CLT is for non-normal populations. So this is the distribution of X bar. This is the distribution of X bar. And these are the confidence intervals. Well, you can find this soft copy of this lecture from my math website, Math by Sir Qadri. Check the description for the link of the math website. Hope this lecture would help you to understand the confidence intervals for MEU. Be good to everyone, good luck, and Allah Hafiz.